Welcome to the Deep Dive. Today we are strapping in. We're taking a journey into the engine room of modern civilization.
The industrial world.
Exactly, the industrial world of heavy machinery.
Yeah.
We're going deep into the systems that keep everything, from oil flowing to factories humming.
We're talking about all that rotating equipment.
Yes, the rotating equipment, those massive fans, the pumps you can't live without, motors, compressors.
And if one of those has a problem, a hiccup.
Or worse, a catastrophic failure. It's not just a maintenance issue. Your entire operation can just grind to a halt, an expensive, sometimes dangerous halt.
It really is the heartbeat of industry, and the source material we're looking at today, it details the work of specialists who operate right there at that critical point. They're the ones tasked with solving these mechanical problems that can often seem, impossible.
And they do it with this blend of old school human expertise and some really next generation tech. So our mission for this deep dive is pretty straightforward. We want to pull out the key pieces of knowledge about how these specialists actually deliver that kind of industrial reliability.
Lasting reliability.
Lasting reliability. And we're focusing on one team in particular for our sources called Vibe.FX.
They summarize their core mandate like this. If it rotates, we can troubleshoot it, balance it, align it, engineer it, analyze it, fix it.
Wow.
So that tells you right away this isn't just some simple repair service. This is an integrated problem-solving unit.
And the makeup of that unit is interesting, too. It's a mix, right?
It is. It's a purposeful mix of highly skilled millwrights, the people on the ground who really get how machinery physically works.
The hands-on experts.
Yes. And they're paired with mechanical engineers who bring that, analytical and design expertise.
So you're not just fixing the machine in the moment, you're also designing the permanent solution.
That's the idea. And they back that up with a real commitment to quality, holding themselves to some of the industry's toughest standards.
The sources mentioned a couple of those, didn't they?
They did.
Yeah.
Rigorous standards like API Spec Q1 and ISO 9001. And if you're in a high-risk sector, say oil and gas, that API Spec Q1 certification,
That means something.
it means a lot. It tells the client that this is not amateur hour. They're adhering to standards built for, extreme precision and reliability.
That builds a huge amount of trust before they even get to the site. Okay, let's broaden our focus a bit. Let's talk about the sheer range of equipment and industries they're actually covering.
Right. When we say rotating equipment, it's really the workhorses of industry.
So what's on the list?
The sources list pumps, of course, huge compressors, large electric motors, generators, and a really critical piece that sometimes gets overlooked. Industrial air-cooled heat exchanger systems. Most people just call them by the acronym ACHE.
ACH. Okay, let's pause there for a second because that might be a new term for some listeners. What is an ACHE system exactly?
Think of it like a gigantic radiator for an industrial process.
Okay.
They use the air around them to cool down process fluids, and if they fail, the whole system can overheat or just become incredibly inefficient.
So they're big, they're vital, and they depend entirely on those huge rotating fans to work.
100%. And you see these things everywhere. Industrial oil and gas, heavy agriculture.
Where downtime would be a disaster for your yield.
A total disaster. And in institutional facilities, too, where you just need things to run continuously.
Okay, so anywhere the continuous rotation is absolutely mission critical. That brings me to their philosophy, which the sources describe as a full scope or turnkey approach. That sounds like they handle everything.
That's precisely it. When they're working on, say, an industrial pump or a compressor, they offer full scope installation.
Which is more than just plugging it in.
Oh, way more. It goes far beyond just bolting a new machine down. It's about making sure the physical installation itself is mechanically sound.
How so?
So that means doing code-compliant work, using expert laser alignment, and this is a big one, focusing on the foundational elements, the base plates and the grouting.
You know that detail about the base and the grout?
Right.
It's surprising how much the sources emphasize that. Why so much focus on the concrete under the machine?
Because a bad foundation basically guarantees failure down the line.
Right.
If you have a pump sitting on an unstable or an improperly grouted base, it's operating under constant hidden stress.
And that stress has to go somewhere.
That does. It becomes vibration. And that vibration just eats away at your seals, your bearings, your couplings, everything. It leads to premature failure.
And we actually see that confirmed in the client feedback. There was a quote from Drew Bonin. He said he uses Vibe.FX not just for the annual vibration check, but to actively review and correct existing pump installations, focusing specifically on those bases and the grouting.
It's the perfect example. It's that overlooked detail that really dictates how long the whole asset is going to last.
So the high-quality physical install is directly tied to the reliability.
Absolutely. But the turnkey approach adds more layers. They also integrate planning and scheduling services.
Project management, basically.
Exactly. In these complex jobs, project coordination, resource planning, those aren't luxuries. They are necessities to keep a project on track and avoid these cascading delays.
So they're not just showing up with tools. They're showing up with a whole logistical plan.
A whole command structure.
Right.
And they finish it all off with a final safety net, commissioning and startup services.
The final check.
The final comprehensive check. After all that complex work is done, you need a system test, a formal handover. This makes sure the equipment performs to the exact spec from day one. It minimizes those stomach-dropping surprises at startup.
They're mitigating risk at every single stage.
The entire asset lifecycle.
And it seems to be working. I mean, for context, the company's been around for 20 years. They serve clients all over North America and even beyond. And they've recently opened a new location in Edmonton.
At 2407 80th Avenue. So they're established and they're growing right along with the industry's demand.
All right, let's shift our focus now from the scope of the work to the diagnostic capabilities. To solve a problem that seems impossible, you have to be able to see things that are, well, invisible. So what kind of specialized tech are they using?
So the sources highlight a few key things. Vibration analysis is still, a core foundational service.
The classic approach.
It's the classic. It's used to find those common issues like imbalance, bearing problems, or misalignment. But they're integrating several other technologies to get a much deeper level of insight.
Okay, let's zero in on the one that really stood out to me from the material. Motion amplification.
Aye.
I mean, that sounds like something out of a science fiction movie. What is it? Why is it such a game changer?
Motion amplification is. It is truly fascinating.
Okay.
So traditional vibration analysis gives you numbers, right? A frequency spectrum that tells you where the energy is.
It gives you data.
It gives you data. Motion amplification, on the other hand, it uses these specialized video cameras and software to measure and visually enhance subtle movements in machinery that you could never see with your naked eye.
Wait, so instead of just looking at a chart that says high vibration here, you're actually filming the machine. And the software exaggerates the tiny movements, the flex, the bend, whatever it is.
That's the perfect way to put it. It's like a slow-motion cartoon of the problem.
Wow.
You are literally watching a component shift or vibrate or rattle in real time. It lets you instantly pinpoint the root cause.
Whether it's a loose bolt or a foundational issue.
A loose bolt, a pipe strain, a crack in the base, you see it. It turns diagnostics from just analyzing numbers into visual confirmation. It makes troubleshooting so much faster.
Incredible.
Yeah.
What other tools do they use to see what's happening beneath the surface?
They also use infrared thermography.
For heat signatures.
Exactly. It's essential for spotting things like overheating bearings or bad electrical connections before they fail. And once that diagnosis is done, they move right into the corrective phase.
And the corrective solutions they list are really specific. Laser alignment, static and dynamic balancing. But then there are two more. Vapor scrubbing and custom-engineered solutions. We know alignment and balancing. What is vapor scrubbing? Why is that a fix for rotating equipment?
Yeah, that's a great question, and it shows the nuance here. Vapor scrubbing is it's a specialized process to purify steam or vapor inside a closed industrial system.
Okay.
Think about power generation or certain processing plants. Impurities in the vapor can cause corrosion, they can damage turbine blades, or degrade pump parts over time.
So by cleaning vapor.
By ensuring the purity of the medium that's flowing through the equipment, they're extending the life of the rotating parts it interacts with.
It's an upstream fix for a downstream problem.
Precisely. It shows they're looking at the whole environment, not just the machine itself.
So let's talk about the future of this work, moving from fixing problems to predicting them. The sources mention a predictive maintenance platform and AI integration. How does that push things forward?
Well, this is the big shift from being reactive to being proactive. And it's all powered by data.
Right.
Their predictive maintenance platform, it doesn't just monitor things, it analyzes real-time equipment behavior and failure patterns using AI.
So instead of waiting for the motion amplification camera to see a big rattle, the platform is looking at the data trends and saying, hey, based on these tiny shifts in temperature and vibration over the last few weeks, This machine has a 90% chance of failing in the next 2 months.
That is exactly what it's doing. It allows them to suggest these timely interventions like, replace a bearing, adjust a lubrication cycle before a catastrophic, unexpected failure can happen.
And if you zoom out, that's the real value.
That's the core value proposition. They're using data to extend the life of the machinery, to optimize reliability, and most importantly, to dramatically reduce that unexpected downtime.
Which is the biggest cost for most of these places.
The single biggest operational cost, no question.
That makes a ton of sense. And we'll get to the actual dollar savings later. But first, let's go back to those ACHE systems we mentioned.
Right. This is an area where they really claim a lot of specialization.
What do they say?
Vibe.FX calls itself the first Canadian-based turnkey company for optimizing the rotating parts of air-cooled heat exchanger systems.
So that's their niche.
It implies a deep, deep vertical expertise. They understand the mechanics, the thermodynamics, the whole process of how ACHE systems work inside and out.
And if they're handling the whole turnkey solution, what does that actually involve? It can't just be tuning up a fan blade.
No, it's a full spectrum of service and supply. They have in-house design for custom solutions, they source parts globally, they do the full installation and the ongoing maintenance. They're not just a service company, they are a critical supplier for high-efficiency, low-noise ECHE fan parts.
Can you give us some examples of those parts?
Sure. We're talking about whole fan assemblies, specialized belt drives, tip seals, which help minimize air leakage,
So efficiency parts.
efficiency and performance parts, electric motors, custom inlet bells. But maybe the most interesting part mentioned is something called the patented DG2 anti-rotation device.
An anti-rotation device, what does that do?
So on these really large ACHE fans, when the motor is off, the wind can actually cause the fan to spin backward. They call it windmilling.
Ah, I can see how that would be a problem.
It's a huge problem. That unexpected rotation creates a ton of stress on the gearbox and the motor when you try to start it up again. The DG2 device is engineered specifically to prevent that backward spin.
Protecting the whole drivetrain.
Exactly. It's a small mechanical solution that solves a major operational risk. It ensures a reliable startup every time.
That's fascinating. Protecting the equipment from the weather, even when it's not running.
Yeah.
Okay, we've covered the services, the diagnostics, the ACHE specialization. Now for what really matters.
Yeah.
The final segment, the measurable impact. Show us the numbers.
This is where it all connects back to the bottom line, right? The sources give us some hard quantitative results from clients that really prove the value of this kind of work.
Let's start with temperature. Quentin North, after some fan-related upgrades, saw the outlet gas temperature drop by. Get this, 20 to 24 degrees Celsius.
Which is just a gigantic thermal shift.
It seems huge. Why does it matter so much?
Because in these industrial processes, stability and temperature control are everything. A 20-degree drop means you've dramatically improved your process efficiency, maybe even your capacity.
Right.
It means the system is just working way more effectively, and it's less likely to trip or run poorly on really hot days.
Which is a perfect lead-in to the production wins from Randy Peterson. He described a situation where, after they installed new inlet bells, they could keep their operation running in peak 34 degrees Celsius heat. Before, they had to cut production when it only got to 30 or 31 degrees.
That's a direct increase in their operational envelope. A small mechanical optimization, the fan parts, the inlet bells, let them keep producing through a summer heat wave.
They turned 4 degrees of ambient temperature into continuous revenue.
And avoided a costly shutdown. Exactly.
And then there's the straight-up dollar savings. Andrew Cameron cited work Vibe.FX did, fan pitch adjustments, cleaning. That contributed to an estimated $270,000 per year flare reduction.
And that number is a perfect illustration of how mechanical efficiency connects to economic and environmental outcomes.
Explain that connection.
So flaring is basically burning off waste gas. When your ACHE system runs poorly, the whole process is less efficient, which can mean you have to flare more gas to manage pressure.
I see.
By optimizing the fans and cleaning the exchange surfaces, they improved the system's efficiency, reduced the need for flaring, and delivered a $270K annual cost avoidance.
Amazing. And one final data point from Paul Emberton. He noted a 5-degree drop in approach temperature even while the ambient temperature went up by 10 degrees.
Right, it's a slightly complex way of saying their cooler bundles, the actual heat exchange surfaces, got a lot closer to their full theoretical utilization.
They're getting more cooling out of the equipment they already have.
Way more cooling, all by making the rotating parts work better.
So what's the big takeaway for you, the listener? We've gone from the grout under the base plate to patented anti-rotation devices.
It means that industrial reliability is not some happy accident. It's a calculated achievement. It's driven by specialized, deep expertise.
And the proof is in the results.
The proof is absolutely in the results. Those temperature drops, the flare reduction, the increased utilization, they prove that when you combine deep mechanical knowledge from millwrights and engineers with high-precision tools like motion amplification and predictive AI, you get quantifiable, repeatable gains in performance.
You're not just fixing things.
You're selling reliable performance, and it's all backed by hard data and lasting quality.
They aren't just chasing the symptoms of a breakdown. They're ensuring the heartbeat of industry is strong, safe, and delivering everything it possibly can.
And that professionalism, that tech, it brings us to our final thought for you to explore.
Yeah.
We've seen the power of predictive maintenance and AI in this space. We're already past just reacting to problems. We're anticipating them.
So the question is, what's next?
Exactly. How soon will this kind of specialized expertise shift entirely from correcting detectable failures to operating in a true anomaly prevention mode, where the goal isn't just to predict a failure, but to use data and machine learning to proactively tweak operational parameters so that the mechanical anomaly never even gets a chance to register as a detectable vibration pattern in the first place? The focus is shifting to absolute, continuous prevention.